The next chapter that we're going to be starting will be Chapter 11 on probability. Before we get started on Lesson 1, I'm going to review just a little bit. If we have the numbers 5 times 4 times 3 times 2 times 1, we just multiply that across and get 120. If I have the numbers 4 times 3 times 2 times 1 over 3 times 2, I can cross out the 3 on 2 on top with the 3 and 2 on bottom because it's all multiplication. So this answer would just be 4. If I have the equation 7 times all the way down to 1 and 4 times 3 times 2 on bottom, I can cross out all the 4 times 3 times 2 on both top and bottom. And if I would multiply that in my calculator or in your head, I would get 210. And finally, if I have 8 all the way down to 1 over 4 times 3 times 2 times 1, I can cross out one whole parenthesis of 3 times 2 times 1. And then I can reduce on both top and bottom. 4 goes into both 4 and 8. 3 goes into 6. And I can take a 2 out of the 2 I have left over from the 6. So on top, I'll have 2 times 7 times 5 over 1, which would be 70. So our first lesson is on combination, or permutation and combination. So the first two questions I have are just fundamental math questions. If I have a make your own adventure story, you can choose 6 starting points, 4 plot choices, and 5 different endings. How many total different adventures are there? Well, if I have 6 spots where I can start from, and then I have 5 ending stories and 4 plot choices. So if I multiply those all across, I get 120. So there's a total of 120 different stories that I could have in this Make Your Own Adventure book. If I have a password that is 4 letters followed by 1 digit, uppercase and lowercase are 2 different combination choices. So there's 26 total letters. If I have both an uppercase and lowercase, that means there are 52, because I have to multiply this by 2, different choices that I can pick for letters. For the first letter, I have 52 different options that I can pick. For the second letter, I also have 52, because it says that it doesn't matter if they repeat. So I have 52 different choices for my first, second, third, and fourth letter. And then it's followed by 1 digit. When talking about digits, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I still have 10 different digits I can choose because 0 is included. So if I multiply that whole thing across, I get 73,116,160. So that's just if we want to find the total different ways possible for combinations. Now we have permutation. Permutation is when I'm given a group and order is important. So this is a lot of times we're talking about first, second, and third, or president, vice president, or swimming the first heat and not the second heat. So it matters if you're going to be first than third. And factorial is a number, if we have a number with an exclamation point behind it, that's a factorial. Factorial of 0 will always equal 1. An example here, if I have the factorial of 6, I write it as 6 with an exclamation point, and that means 6 times 5 times 4 times 3 times 2 times 1. So when I'm talking about permutations, and if I have 7 people choose 3, example would be at first, second, or third, This is the formula that I use. N is going to be the total number of people to choose from. R is going to be how many people you choose. So if I have 7 people and I'm choosing 3 of them, I would have 7 factorial over 7 minus 3 factorial. That's the same thing as 7 factorial over 4 factorial. So if I write this out, I can cross out the 4, 3, 2 on both top and bottom. So I'm just left with 7 times 6 times 5, which would be equal to 210. Now, if I have a question, how many ways can a club select a president, vice president, and secretary out of a group of 5? Since order matters here, I would use permutation. There's a total of 5 different people. I'm choosing 3 of them. So I'll have 5 factorial over 5 minus 3 factorial, which is equal to 5 factorial over 2 factorial. When I write this out, my 2 and 1s will always cancel out. So you should always have numbers on the top and bottom canceling each other out. So here would just be 5 times 4 times 3, which is equal to 60. Awards are given at a costume party. How many ways can you pick most creative, silliest, and best costume? There's 8 different contestants, and no one gets more than 1 award. So this again will be permutation because best costume is going to be different than silliest. There's 8 different people, and I'm choosing 3. So this would be 8 factorial over 8 minus 3 factorial. Now when I'm writing this out, I know that my 5 factorial will cancel out with everything on top below 5. So I'm just going to have 8 times 7 times 6. If you want to write out the whole equation and cross the numbers out, that's fine too. But just to save time, I'm going to write 8 times 7 times 6, which means there's 336 different ways that we can choose for best costume, or silliest, or most creative out of 8 different people. Combination is where grouping does not matter. If I have 3 different items, permutation would get me 6 different ways that I can have a combination of those 3 items. Combination, there's only one because order does not matter here. So if I pick A, B, C, that's the same thing as picking C, B, A, or B, C, A. So this is the difference between permutation and combination. Order does not matter. I still set it up the same way as permutation. This N still is the total number, and the R is how many you're choosing. So if you look, I still have, this is what permutation formula is. Now to include, to get rid of the other combinations for permutation, we also have to divide by R factorial. So if we have 7 choose 3 here, this would be if I have 7 people, I'm choosing 3 people to go to the gym. It doesn't matter how I choose those 3, because those are the only 3 that are going. It'd be 7 factorial over 3 factorial, 7 minus 3 factorial. So if I write this whole thing out, 7, 6. I can cancel out my 4, 3, 2, 1 on both top and bottom. And then I can cancel this 3 out with my 6, and the 2 out with the remaining 2. So I'll just have 7 times 5, which is 35. So Susie's going to adopt puppies from a litter of 11. How many ways can she choose 3 puppies? So I have a total of 11 different choices, and I'm choosing 3 of them. So this would be 11 factorial over 3 factorial, and then 11 minus 3 factorial. This is another way. If you want to cross out right away, you can do that. For this first example, I'm going to write out the whole equation. So all my 8's cancel each other out. So I could have saved time if I remember that all my 8's cancel each other out. And then I can cancel this 3 with the 9. And I can cancel this 2 with my 10. So I'll have 11 times 5 times 3, which is equal to 165. So the reason that order does not matter here, she's still going to get the same exact 3 puppies. It doesn't matter if she picks the white one, black one, then brown one. It's still that combination of 3 puppies. The swim team has 8 swimmers. 2 swimmers will be selected to swim the first heat. How many ways can the swimmers be selected? Now this is combination because it doesn't matter the order that you pick the 2 swimmers. If I said I need my fastest swimmer for the first leg and my second fastest for the second leg, that would be permutation, because it will matter with the order if you're going first or second. They're not telling you it matters for the first and second order. So this still will be combination. There's a total of 8 different swimmers, and we're picking 2 of them. So this would be 8 factorial over 2 factorial, 6 factorial. Now again, to save time, I'm just going to write the 8 times 7, because everything below will cancel out with my 6 factorial over 2 times 1. And I can reduce my 2 with my 8. So I'll just have 4 times 7, which is equal to 28. So when you're dealing with these problems, you should always think, does order matter? Would you care about getting first or third? I'm guessing you're going to say yes. So always be aware of, does order matter?